Hello and welcome to yet another episode of GDG Tech Sessions. My name is Rustam. I will be your host today, and we have yet another great talk ready for you. Before we get to the talk itself, I just want to say a few words about what GDG Tech Sessions are. We have started in May 2020. We've had a lot of interesting talks. All of them are published on our YouTube channel, so you're more than welcome to go and revisit them whenever you want. And we've had over 15 tech sessions, different sessions, and we have had a lot of interesting topics on a wide range of topics, really. One more slide before we get to our guests for today. That's the presentation of the team behind the GDG Tech Sessions. So there are four of us, as you can see on the screen. So it's three from Portugal, three of us from Portugal, and me from Norway, Oslo, Norway. So that is a very, very short introduction about who we are and what we do. I think it's time to bring our guests for today that will be talking about how to build a cloud-native application with Quarkus and Google Cloud Functions. So, Loïc, it's great to have you here. It's great to see you at our GDG Tech Sessions, and also it's great pleasure to see a fellow GDE to present. So welcome.
Thank you and welcome.
Thank you very much. I think I'll leave the stage to you, and I will just one more thing before I'll be leaving you. I will encourage people to ask questions in YouTube chat, and then when all the questions, we'll collect them and we'll ask them at the end of your presentation. So I'll be appearing again with the questions. Hopefully there will be a bunch of questions. So please do write them in the chat, and we'll keep track of them. So now I think it's time to leave the stage to you and take it away.
Thank you. Hello, everybody. So building a cloud native application with Quarkus and Google Cloud Functions. So first, who am I? So I'm Loïc Mathieu. I'm an IT consultant and a trainer at Zenika Lille. So I'm coming from the north of France. You can contact me on Twitter or by mail, loic.mathieu@zenika.com. If you're curious about what I do, you can check my GitHub account, or you can read the articles I publish on my website, loicmathieu.fr. On my website, I usually talk about Java, Quarkus, GCP, and some other stuff, but a lot about Java. I'm a GCP Google developer expert, and I'm also a Quarkus contributor. So Quarkus, it's supersonic subatomic Java. So what does it mean? Quarkus has been made from the beginning to be deployed inside a container. It's really different from other Java framework that exist before the containers and that have not been designed for running inside a container. Quarkus has really been designed for running inside a container, running inside a cloud, running inside Kubernetes. So it's really optimized to run in those runtimes. When you talk about supersonic and subatomic, it's really because Quarkus will start very quick, so it's supersonic, and it will use very little memories. This is why it's subatomic. Usually you see this image that explain these two terms. So if you take the part of the image in the upper right corner, you see a comparison of the resident set size of traditional application. So it's res plus CRUD, create, read, delete. So it's just an application with REST API and using GPA to access the database, for example. If you use a traditional cloud native stack, you have usually an application that uses 200 megabytes. With Quarkus, you can have a resonance set size around 150 megabytes. When we talk about resonance set size, it's not just a Java heap. It's a heap plus the metaspace plus the thread stack plus some memory area internal to the JVM. So you can really run Quarkus with a very small heap. I'm working on an application currently that is Kafka based. So there is no database, and we deploy in Kubernetes with pod with 506 megabytes, so it's really small pod. And it's working correctly because when there is no database involved, you can have a Java heap of 50 or 60 megabytes, and it's working fine. So Quarkus also starts really fast. It's very important in containers environment like Kubernetes because you want to be able to auto scale your application, to scale very fast, to destroy very fast also your application, to be able to recreate it. And Quarkus starts really, really fast. So if you take the lower part of the image, again, you have the boot time plus first response time. Quarkus does not a lot of things lazily, but some frameworks do. So when we compare the starting time of application with Quarkus, we compare it for the boot time of Quarkus plus the first response time. So it's just calling an endpoint that say hello, but so to be sure that everything is started. And if you compare a traditional cloud native stack that will take 9 to 10 seconds to start, Quarkus you can start very quickly. Here in the image, it's said in 2 seconds, but with recent Quarkus versions, you start in 1.5 seconds inside a container with only one CPU. So it starts very quickly. Okay, what I really love about Quarkus is that it unifies imperative, asynchronous, and reactive pragmatism. Okay, just sorry. So it unifies imperative, asynchronous, and reactive way of coding. So when we write a piece of code in imperative mode, you just use, for example, you implement, for example, a REST endpoint that say hello. You just return the object, you return the hello string. When you want to switch to asynchronous, you just return a completion stage. When you want to switch to reactive style programming, you return a publisher, so a reactive string publisher, or you can return reactive type. Quarkus has mutiny, it's a Quarkus reactive type, but you can also have commenters for Java, for example, and you just return it in your REST endpoint. Then the Quarkus engine will, for completion stage, will resolve the completion stage. For reactive types, it will subscribe to the types and wait for completion of the types. So really, the complexity of using asynchronous of reactive is totally done at Quarkus runtime level. So it's really easy to switch from one way of programming to the other. Quarkus is really focused on the developer experience, what is called developer joy. So it was really important for the beginning, and it's still really, really important. And there is a lot of functionality that are focused on developer productivity, like unified configuration, like the live reload. So Quarkus has this dev mode when you start Quarkus, and then you can update your code, and Quarkus will restart the application automatically, not in continuous, but when you first use again your application. So it's really effective. You can add extensions, you can do almost anything, and it will always restart your application. Usually I just start my application on the morning, and sometimes I stop it at the end of the day, but sometimes not, and it's never crash. It's really really effective. And on this special dev mode, you have a lot of other functionality. You have continuous testing, so you can just launch your test suite inside the dev mode on a separate command, and it will just relaunch your test each time you update some piece of code. You have dev services that is able to start a service like a database or a Kafka broker automatically when you start your application or when you launch your test. Quarkus are really very few boilerplate code. They try to have as less boilerplate as possible. There is no application class, no configuration class. So everything is in the configuration file, and everything is pre-configured by default to work with send default and to work on the dev mode. Quarkus also facilitates native completion. So if you compile your application as a native application with GraalVM native image tool, it's really an area where Quarkus do a lot of stuff, also facilitate a lot of stuff for native support. But more important is that Quarkus is based on best-of-breed libraries. So usually when you use Quarkus, in fact, you use very mature library that you already know. Quarkus is based on Vertex, all its reactive core, Hibernate to access database, REST-easy to write REST endpoint, and it's based on standards when possible. So it uses Jakarta EE standards and all the Eclipse microprofile standards for microservices. So it's really great because you can have developer experience close to G2E application or close to other microprofile implementation if you already know a microprofile implementation. Okay, so Cloud Native. When we talk about Cloud Native, we usually describe it as an approach to software development that uses cloud to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. So Cloud Native, it's a technology. It's a technology stack such as containers, microservices, serverless functions, and immutable infrastructure. So it's an architectural style that uses the capacity of a cloud provider to build an application. Quarkus have a lot of Cloud Native support via multiple extensions. An extension in Quarkus is just an integration of a technology. So it's a Maven dependency that integrates a technology. So there is serverless function as a service support like AWS Lambda, other functions, and Google Cloud Functions. There is a client there is a Kubernetes client to be able to access the Kubernetes clusters where your application is deployed. There is resource generation for Kubernetes and OpenShift. You can configure your application via Kubernetes config map, secret, and service binding. There is a Vault extension to put your secret in Vault. There is some extension to use Amazon services like S3, SNS, SQS, and there is some extension to use Google Cloud services like storage, Pubset, and BigQuery. There is also a portable API to write serverless functions, so your function can be deployed in different cloud providers. This is called Franky, and with Franky you can write functions of different types, background functions to respond to event, HTTP functions, and Knative or cloud event functions. So I will make a demo about building a cloud native application with Google Cloud Functions. So I will use the Google Cloud Functions set of extensions. With this set of extensions, you can write Google Cloud Functions with the Google Cloud API, okay? With one of Quarkus HTTP API like JAX-RS, Reactive Words, Servlet, or with Franky. And I will also use some extension from the Quarkus Google Cloud Services So it's an extension pack, a set of extensions for various Google Cloud services. Currently, it supports BigQuery, Bigtable, Firestore, Pubsub, Secret Manager, Spanner, and Storage. And it's the extensions are not in the Quarkus core repository, but on a community-driven repository, what is called the Quarkiverse, just because the core repo of Quarkus is too big. Okay, this is a demo I will do. This will be an application that will store bookmarks, and then you can retrieve those bookmarks with an HTTP API. But as I'm not a front-end guy, I will use gsutil to send a bookmark to store to my application via a simple JSON file. So a bookmark will be a JSON file. I will use gsutil to upload the JSON to cloud storage. Then our first function will be triggered by a storage event. Will load the file and send the content of the file to Cloud Pubsub. Then a second function will respond to a Pubset event, will then store the bookmark inside Cloud Firestore. Cloud Firestore is a NoSQL database of Google Cloud. It's document-oriented. It's the successor of Datastore. And when all this will be done, I will have my bookmarks inside Cloud Firestore and will be able to use an HTTP Cloud function to retrieve them. Okay, so coding time. I'll just, if there is a question, no, okay, there is no question for the moment, so we will wait at the end. Okay, so I will develop the first function. So the first function will be a background function that will respond to a storage event. And on this storage event, it will load the file that that was uploaded to cloud storage and send the content of the file to Cloud Pubsub. So this is written in Java. The extensions are just included inside the application just as standard map and dependencies. Here you can see the Quarkus Google Cloud Functions dependency. This is a dependency that will allow me to write a cloud function as a Quarkus application. Then I also added two other extensions, one for cloud storage and one for Cloud Pubsub. So the storage function will be a background function. So I will write it by implementing background function from the Google Cloud API. And it will respond to a storage event. And the storage event is just an event that is specified inside Google Cloud documentation. So I just create a simple POJO with all the fields from the event as described inside the documentation. Okay, everything is public just to be able to use it really easily. So this is the event I will receive when I upload a file to cloud storage. The upload of a file to cloud storage inside the Quarkus GCP demo will trigger the function, and the function will receive the storage event. Inside the storage event, there is the name of the object. So I will be able to use this name to retrieve the file that was just uploaded to cloud storage. The only non-standard Google Cloud thing inside this function is that I need to add a CDI application, CDI scoped annotation, so an annotation that defines my function as a CDI bean, so it can be created by Quarkus and retrieved from the Quarkus CDI container. As my function is a CDI bean, I can inject CDI dependencies. So I can inject a bean inside it. So I will inject storage bin. So this will allow me to access to cloud storage via my inside my function, and this object is contributed inside the CDI container thanks to the cloud storage extension. So first I will get the bucket storage dot get the bucket. Then I will get the blob, so the content of the file. And the name of the blob, it's the name of the name of from the storage event. Then I will send this to Pubsub. So sending to Pubsub is a little complex. So I just use an helper class, and I will need also a config property. The config property is coming from my application.properties file. So from the configuration file of my application, I will call it project ID because I need the name of the ID to connect to Pubset. So the name of my project. So this is check. Copy paste. So this is just how you can access config property. So an option from your configuration file inside Quarkus. And here I need to give okay. And this is an helper class, so I will show you the code. So it's just create a topic name, create a new publisher. It creates a message from the content of the file, and then it will just publish the message to the topic and wait for completion. Okay, great. So this function will receive an event with the name of the file uploaded to cloud storage. It will get the bucket, get the file, then send the content of the file to a Pubset topic. I will use Maven to package the application. So using the standard target mvn clean package. This creates inside the deployment folder an aperture with all the dependencies inside it. So you can see it's 30 megabytes. Yes, and then I will deploy it to Google Cloud. So I will use this command to deploy my function to Google Cloud. So gcloud functions deploy Quarkus GCP demo storage. So it's the name of the function. The entry point, it's not my function, it's the Quarkus background function. This function will start Quarkus and locate my function inside the CDI container. And I configure my function to be triggered on the google.storage.object.finalize event on a bucket called Quarkus GCP demo. So the bucket is passed via the trigger resource parameter. I set the runtime to Java 11 and the source to the source repository of my function to target/deployment. So it will take a few a few tenths of seconds, up to 2 minutes to build and deploy my function. So I will implement the Pubset function. So the Pubset function will be triggered by a message inside a Pubset topic, the message that was sent by my storage function, and will just store the content of the message inside Cloud Firestore. So, like the previous function, it's just use the Quarkus Google Cloud Functions extension, but it's also use the Quarkus Google Cloud Firestore extension to be able to access Firestore API. So it's just another background function, but that will receive a Pubset message and as the background event and a Pubset message. Inside it, you have data. This is the message itself, the content of the message. So I will first inject a Firestore object to be able to interact with Firestore. So I will so here I just get the message from the event, and I will just decode it because the event, it's the message is base uncoded, base 64 uncoded. Then I will just get a collection first. So in Firestore, you store in fact documents. So your data is stored as a document, like a JSON document, if you want, inside a collection. So I'll just get a collection from Firestore. So I will start my bookmark inside the Bookmarks Firestore. There I can create a new okay, then I will create a new document. First, I will create a bookmark object because on Firestore you can send a document as a Java object. So the bookmark object is just a simple project with all the fields that correspond to the bookmark JSON. And I will use Jackson to deserialize the message as a bookmark. Then I will create a new document. So to create a document, excuse me, I use a document method. I use the ID of a bookmark as the path of the document. Then I will just put the I will just create the new document with my bookmark. And that's it. Just I will just get it. So Firestore API is asynchronous. So if you want to be sure that your function ends when the document is created, you need to call get. So this is my Pubset function, and I will, like before, build it and deploy it. use the same kind of command than previously to deploy my Pubset-based function. So gcloud functions deploy Quarkus GCP demo Pubset. This is the name of my function. The entry point is the Quarkus background function, runtime Java 11, but I will trigger it on the event google.pubset.topic.publish, so the publication of a message inside a Pubset topic, and the trigger resource will be the name of my Pubset topic. So during this time, my first function, so the storage function, was deployed. I can access its log. Here I just have a shell script with the code to access the log. And you can see here that my function was started a few minutes ago. So it started in 2 seconds. In fact, Cloud Function runtime is based on Jetty, so you have approximately 1 second to start Jetty, and you can see that Quarkus was started in 1 second. You see here, it started in 1 second and 187 milliseconds. And here you can see the list of features, the list of extensions that Quarkus uses. So it uses Google Cloud Functions, Google Cloud Pubset, Google Cloud Storage, and on some extensions for reactive stuff, because we integrate Google Cloud Functions is integrated with Vertex at the core of Quarkus. Okay, great. So now my storage, my Pubset function is also started. So I can also have a look at the logs, and I see that it's also started in 1 second and 200 milliseconds, and I can also see here the list of features. Okay. The function uses, this is the standard function size, so it uses 256 megabytes of memory. And that's all. So the last function will be an HTTP function. The purpose of the last function is to respond from an HTTP request to retrieve all the bookmarks from Cloud Firestore and to return it serialized in JSON. So this function implements HTTP function. Again, it's from Google Cloud Library. It's from the Google Cloud API. And you implement an HTTP function with the service method that takes an HTTP request and an HTTP response. And this is also annotated with application scope like a background function. So here I will also inject a Firestore object, and I will use this Firestore object to list all the documents from the Firestore collection. Documents will list all documents. So this is this is document snapshot, I think. So I will iterate over all documents. document reference. So I will iterate about on all documents of the collection. Will get the document. So this is a reference to a document. I will get the document and it's an asynchronous call, so I'll need to call get again. Then I will create a bookmark. Here I have a bookmark object. This is more or less the same object that I use to serialize to in JSON a bookmark on the Pubset function. And here I have just a small helper function that creates a bookmark from a document. I will show you the code just later. And I will just put everything inside the results. Okay, so the from method of the bookmark class is just an helper function that will set all the field of a bookmark object from a document snapshot. So this is how you get a field from a document snapshot by its name. And I will just need to understand why it doesn't compare. Yeah, okay, it's okay now. Great. And then I will use Jackson again to serialize my list of bookmark and write it inside the writer of the HTTP response results. Okay, great. So I access the collection, the bookmark collections. For each document, I get the document. Then I create a bookmark from it. I add this inside a list. And then I use Jackson object mapper to serialize the list as a string. And I write this string inside the response of my function. So I will package it. Sorry, with Maven, and this will work like a background function. It's not very different. Yep, and now that it's done, I can use jcloud to deploy it. So jcloud functions deploy Quarkus GCP demo HTTP. This is the name of my function. Allow unauthenticated to allow an authenticated user to access my API. Then entry point, it's the Quarkus HTTP function. This function will start Quarkus and locate inside the CDI container of Quarkus my function. And the trigger event, it's an HTTP event. This will take some time to deploy, but we can just try the function. So to try the function, I will use JSUtil to send a bookmark inside the my Quarkus GCP demo bucket. So I have a bookmark as JSON inside a repository, and I can just send them. Okay, I have 3 bookmarks, and I will upload those 3 on the Quarkus GCP demo bucket using JS util. So if you want to have a look at a bookmark, this is just a simple JSON. You see, okay. So this JSON will be put inside the Quarkus GCP demo bucket. This will trigger my function, the first function, so the storage function. The storage function will send then the JSON. Oh, okay, this is not working. Okay, this is because I use create instead of set. Okay, fun. Okay. The Pubset function didn't work because there is already documents inside my collection, and as I use here create, it cannot create a new document because document already exists on this path. So I need to use set instead. But it receives the messages. Just redeploy it. The HTTP function will work because there is already some data inside the collection. When the HTTP function is deployed, you have its URL here, so you can just use curl to access it. I will use. I'm not sure. I don't know if GQ is installed. And okay, you see that there is function. I will just try with. Yeah, there is no GQ. This is a brand new laptop. It's better to install GQ to more easily see the JSON. Okay. Okay, so you see there is 3 JSON. There is 3 bookmark inside my database, and the HTTP function just returned them. Okay, so everything working more or less. I will just send again the first bookmark to be sure that my Pubset function works. And no, I don't have the log yet. Yes, okay. And here you see it received a message and successfully started in Firestore. So this is an example of how to build a cloud-native application with Quarkus deployed as a GCP function. But I'm not very satisfied about the fact that we use the GCP API. With this, we are coupled with GCP API, and you see for HTTP, this is really low-level API. So I will show you how to build your function in a provider independent way. So instead of using the Quarkus Google Cloud Function extension, I will use the Quarkus funqy-google-cloud-function extension. This extension will allow me to write a GCP function as with Franky. Okay. I did the project, and here I will normally don't have any more access to the cloud storage, to the cloud function API. So I will just write my function as a funky function, and that's it. I just transform GCP background function into a funky function. So I just remove everything that is linked to Google Cloud Function API, and I annotate with @func the function that will be called when the method that will be called when the function is triggered. That's all. Begin my application, and I will use almost the same gcloud command to deploy my application. It's just that the entry point is different. So this is this one. It uses the Franky background function entry point. I can do the same for my Pubset function, but I will not do it because there is nothing more to show. So now I will show you how to write HTTP function with JAX-RS, so with REST-easy, with the REST-easy dependency. So I switch from Quarkus Google Cloud Function dependency to Quarkus Google Cloud Functions HTTP dependency. And as I want to write my application with JAX-RS, I add the Quarkus REST-easy JSON-B dependency. That's my project. And now I can write my function with the JAX-RS API. So my function will be a standard endpoint, JAX-RS endpoint. Not implement anything, and I will have my method annotated with JAX-RS annotation. So I add the @get annotation. So this method will be called when a get HTTP is done on the root path of my function. And to know that my function is a it's a JAX-RS endpoint, I can just return the list of results. Okay. And REST-easy will serialize it for me in JSON. So I don't have to serialize it manually in JSON anymore. So it's really something that is really more, it's easier to use JAX-RS than to use raw Google Cloud HTTP function support. What's good also is that imagine you want to not only expose an endpoint to get the list of bookmark, but also to get one bookmark. If you write it with Google Cloud HTTP API, you will need to create your own router, in fact, to be able to say, okay, if the path and if the path is slash, I return the list of reference. If the path is slash an ID, I return also only the bookmark corresponding to this ID. But if you want to implement this using JAX-RS, it's really easy because you just create another operation. You annotate it with a set of JAX-RS annotation here to say that my method will be called when there is a get HTTP on the path /id, and then you can just implement the retrieval of a single bookmark. I will not implement it. Now, but yeah, you get the point. So I will package my application and I will deploy it to GCP. Again, I will use a slightly different g-cloud command. I will need to use the Quarkus HTTP function from the HTTP package. And I can just try to date one of my bookmarks. Update the description and say okay, just it's for executing fun, and I will send it again to the bucket just to see if everything works. Last time I did it, it didn't work, so I just give you a heads up. It's possible that it didn't work. I don't know why, but it's a demo effect. No. So the function was, yeah. So the new function was called. This one didn't change. And then I will just access again my HTTP endpoint, and you see that, yeah, it didn't work. Okay, so the bookmark was not updated, but okay, it's not important. It should be demo effect. Okay, this is it. So what you see is that with Quarkus and the Google Cloud Functions extension, you can easily write a Google Cloud function that can use all the power of Quarkus, and you can access easily a set of Google Cloud services via the services extension pack. Thank you for watching. If you have questions, you can ask them now, or you can send me an email or ask on Twitter. And if you're curious, you can also have a look at my blog. I have an article that I wrote a few days ago about Quarkus Google Cloud Functions. If you can, if you can just add the link to the article in the GitHub comment, so people will be able to read it if they want. Oh, okay, thanks, Fernando. If there is questions, I can answer some questions.
Hello again, I'm back. Thank you very, very much for this talk. It's been really, really interesting to listen and to see how you do all these things. So let's see if there is any questions. Feel free to write them in the chat, and we'll read them as soon as we see them. But until then, I think a question that you partially answered already, but it's just I'll ask it anyway. So these things that you've mentioned, I mean, a lot of at least parts of those things can be done probably with just regular Java and then the regular kind of cloud function API and stuff like that, right? So maybe we should mention a bit more, talk a little bit more about when it's a good idea to put things on Quarkus, and when we can just write a regular kind of Java code and just deploy it as a serverless function.
Yes, if you want to make very simple function like the background one, there is not a lot of advantage to use Quarkus, but you see really quickly for HTTP function that just having access to a request object and a response object is very low level. So here you can't have a lot of advantage to use Quarkus to be able to use more advanced HTTP API like JAX-RS or reactive routes. For background functions, it depends if you what you want to do. In fact, I think if you start if you want to have a complex application with multiple components, you can take advantage of CDI. If you need to access a database, you can take advantage of GPA. So yeah, it's really dependent of the size of your application.
Yeah, exactly, and that's actually a really cool thing. What we have done in it's a colleague of mine and we have another talk, so it's a different story. But it's we did this kind of similar thing where we put things into a Quarkus, created a container, and put it on Cloud Run, so which is managed version of Knative instead of Cloud Function. And so we also did this kind of the whole exercise of putting things into a container and deploying it. And also we played around quite a bit with the binaries. So you kind of compile, instead of you go into this binary mode and compile
the native mode. Yeah.
Yes, native mode. Yes.
Yeah. So the native mode, it's really interesting. It's really interesting, but I didn't talk a lot about it. But you can, when you compile your application as a native application, you can't put it inside a very thin container, because you will have just a binary with all your application code and a small JVM inside it. It's a substrate VM. And it starts in few tenths of milliseconds, and it's used very, very low memory. On Quarkus, you can deploy with Cloud Run, with App Engine as Google Cloud Functions, or GT, or everything you want. So we cover the three serverless mode of Google Cloud Functions. Again, I just.
But App Engine, that's flexible, right?
No. You can use App Engine standard.
Cool! I haven't tried that. I wanted to try.
Again, on the chat, if you can add it to the YouTube chat, I just give the link of the deploying to Google Cloud guide from the Quarkus website, and it explains how to deploy using the two App Engine mode, Cloud Run, and how to use Cloud SQL also, because it's not easy. So. Yes, for Google App Engine, it's standard. You really need to follow the guide, because there is some specific things to be done to be able to build a compatible application. But it's just you build an Uber jar and you put your Uber jar into, and it works.
Oh yeah, perfect. That's really cool. I have to try that. I haven't tried that. That's really nice. But so the binary, like native mode, I call it always binary because it is binary. But native mode, it works on Cloud Functions as well, right?
No,
No, it
because
doesn't. Okay.
Cloud Function, it's Jetty runtime Docker.
Oh,
So
yeah, that's right.
really, you deploy a jar, and there is a Jetty server that will just
Yeah,
locate the function in the
that
class
makes
path.
sense. Yeah, that makes sense.
So on a GraalVM native image cannot do any dynamic stuff. So
True.
it cannot just locate a function in a jar file because it cannot load bytecode dynamically like a standard JVM. So
Of course.
everything needs to be known at build time. That's why you can only deploy it inside a container. So App Flex or GKE. Because there is no way currently on Google Cloud to say send this background event to any endpoint. I know there is some event arc functionality that was coming. Maybe they will cover this case for.
Yeah, that part, event arc probably can be very interesting in this case. Actually, yes, that's right. But that makes absolutely very much sense. So that's really cool. That's very interesting because I mean we've seen really crazy startup times when we put it on. When we compiled in native mode, then it was very easy to scale down to zero and scale up from zero with Knative or Cloud Run, and that would be just you wouldn't notice that it was actually at zero, and just like response time
Yeah.
was just really cool.
What's interesting is that as you see, Quarkus start in 1 second inside Cloud Functions. So it's really quick, but it's still 1 second to start. Then you have 1 more second to start the Cloud Function runtime itself. So when you use Cloud Functions, you know that you will have a cold start. I tested Cloud Function version 2, and I think there will be more options for cold start, and there will be a new concurrency mode also, because if you use the current Cloud Function, you see sometimes it starts a new function, but you don't have a lot of loads, so it's not really you don't really know why it starts a new function, so you have a new cold start.
Yeah, that's true. So that's going to be interesting to see how that goes. So we got a question. Oh, that's interesting one. That's a good one. Thanks, Carlos. We'll probably see it on the screen in a second as well. So, as a Java developer, are there any alternatives to dive into Google Cloud? So, the way I read this question, I guess it's more like what can you do as a Java developer, and which parts you can use as on Google Cloud. Oh, like my gut feeling, or what my short answer would be probably a lot of things. I mean, most of those things. But what do you think? What would you say?
If you deploy your function with Quarkus, you can use almost any Quarkus extensions with Google Cloud Functions. There is no reason it will not work.
Yeah.
And as I said, regarding the Google Cloud services, we already support multiple of them. I just saw BigQuery, Bigtable, Firestore, Pubset, Secret Manager, Spanner, and Storage. And if you want to use another service, you can just use directly the Google Cloud API. Is the question if is there any alternative to Quarkus? I know that Spring Boot and Micronaut also have support for Cloud Functions.
Yeah. And also, I again, like if this question was generally as what a Java developer can do on GCP, that's even broader question. I mean, pretty much anything. There's a lot of SDKs on for Java out for the cloud that's official. So you probably will be, obviously anything that runs in the container should run, but also cloud like serverless functions should be fine, and you should be able to do pretty much everything. I would say so. I think
I think there is almost all the cloud services are available to Java developers. So
exactly.
there is an SDK that's for each cloud services.
That's true. So that's a lot of things. I mean, if you haven't tried that before, if you haven't tried Java before, I mean, I think you should try Java and write write stuff in Java. And if you haven't tried it on the cloud, try that as well. I mean, that's, I think, the short kind of a pitch of pushing Java to people. I guess like both of us are Java people. So I mean, we
Yeah.
kind of feel obligated to say that. That's really cool. Any other questions? Any other comments? Any other experiences with Quarkus, Java? I don't know, clouds, anything, serverless? It's a tiny little delay between what happens on YouTube and when it happens when we actually say that. So there's a few seconds. So we'll just give a few more seconds for people to type their questions if they're having any. And while they're doing that, I will show this slide and encourage everyone to support or to join us on various social media accounts that are we as Tech Sessions exist on. So it's like Twitter, even Instagram, Facebook, YouTube. Probably YouTube is the most relevant if you want to follow on the previous talks and see what we have done earlier and rewatch this session or any other sessions. And all the other sessions, all the other like future sessions will be announced on our other social media accounts as well. So if you're not following us yet, follow us on all those channels, and we will be back with some more talks soon. Yeah, I think I don't see any more questions. So I think I will say thank you very much for doing this again with us. And it's been really, really fun. And it's been really great to see the demo. Live demos are always fun. It's always kind of a bit, you get a little bit nervous. It's like, will it work? Will it work this time? And it actually worked really, really nicely. So the demo gods were with us today, I think. And it's always fun to attend your talks. So it's been really fun. Thank you very much. Thank you for being with us.
Thank you for inviting.
All right. And thank you to all of you for watching us. And we will be back. We'll be back soon. So follow our social media channels and you'll see more talks getting announced as soon as we're ready. Thank you. Bye-bye.